So what's up, Angelinians? Good morning, good afternoon, good evening, whatever time you are watching this right now. I'm here, Jerome Sibal, and I'm with RJ Narciso. We're about to explain about sheet pile or sheet pile walls. So first, what is sheet piles? Sheet piles are most commonly made of steel but can also be formed of timber or reinforced concrete. Sheet piles are commonly used for retaining walls, land reclamation, underground structures such as car parks and basements, in marine locations for riverbank protection, seawalls, coffer dams, and so on. So what are the use of sheet piles? First, we have building continuous walls for waterfront structures and for temporary construction wall, building diversion dams such as coffer dams, then riverbank protection, retaining the sites of cats made in earth. But the common use of sheet piles is used to provide temporary and permanent walls in the construction industry. Sheet piling is used as excavation support and for soil retention. It creates a border which keeps the soil back away from the structure. So let's go on to the types of sheet piles. First, we have the according to materials. These are the timber, reinforced concrete, and steel. So what is timber sheet piles? Timber sheet piles are generally used for short spans in temporary structures and to resist light lateral loads. They are typically connected together by tongue and groove joints. The disadvantage of timber piles is that they require preservative treatment and are not generally suitable for soil consisting of stones. And then we have the reinforced concrete sheet piles, which are formed using precast concrete members, usually connected together by tongue and groove joints. They are commonly used in permanent river embankments, canal, and other marine structures. And then, for steel sheet piling, these are long structural sections with a vertical interlocking system that creates a continuous wall. The walls are often used retain either soil or water. The ability of a sheet pile section to perform is dependent upon its geometry and its soil it is driven into. So let's go on to the type of sheet piles according to the structural system. First, we have the cantilever sheet pile and anchored sheet piles. First, what is cantilever sheet piles? These are used where the height of the soil or water to be retained is smaller than 4.5 meters. The various forces acting on a cantilever sheet pile wall are the active earth pressure on the back of the wall and the passive earth pressure on the front of the wall. Then second, what is anchor sheet pile? Anchor sheet pile walls are held above the driven depth by anchors provided at suitable level. The anchors provide forces for the stability of the sheet pile in addition to the lateral passive resistance of the soil into which the sheet piles are driven. So here in the picture is a timber pile wall section. For every pile wall, there is a groove and a tongue that will make them connected. Forced concrete sheet pile wall section, straight sheet piling, shallow arc web piling, the arc web piling, and the Z-pile. But first, what is reinforced concrete piles? Due to the possibility of carrying vertical and horizontal loads as well as bending moments, precast piles are used for the foundation of all sorts of engineering structures under virtually every soil condition. Then, for straight web sheet piles, are designed to form cylindrical structures, generally close, retaining a soil backfill. And for shallow arc web piling and Z-pile, the arc and Z-piles are used to resist large bending moments. For less bending moment, shallow arc piles with smaller sections modulus are used. And straight web piles are used where the web will be subjected to tension as in cellular coffer dams. Next, we have the cantilever sheet pile walls. Cantilever walls are usually used as flood wall or as earth-retaining walls with low wall heights 3 to 5 meter or less. Another thing, the various forces acting on cantilever sheet pile wall are the active earth pressure on the back of the wall and the passive earth pressure on the front of the wall. As you can see, we have the cantilever sheet pile image, which has the large triangle, which is the active earth pressure, and beneath it, it has the passive earth pressure. Then on the other side, we have the fixity. The depth to pile fixity is used to determine the pile moment at the point of pile fixity. In this picture, you can see how the active pressure and passive pressure affects the cantilever sheet pile. Next, we have the anchored sheet piles. Again, what is anchored sheet piles? Walls are held above the driven depth by anchors provided at suitable level. The anchors provide forces for the stability of the sheet pile, in addition to the lateral passive resistance of the soil into which the sheet piles are driven, and when the height of sheet pile is less than 6 meters. But what anchor sheet pile looks like, and what are the designs of cantilever sheet piles? First, we have the free earth support method. This method is based on the assumption that the soil into which the lower end of the piling is driven is incapable of producing effective restraint from passive pressure to the extent necessary to induce negative bending moments. And for the next image, we have the fixed earth support method. The piling is driven deep enough so that the soil under the line of excavation provides the required restraint against deformations and rotations. In short, the lower end of the piling is essentially fixed. Then, we have the anchor plate or beam. An anchor plate, floor plate, or wall washer is a large plate or washer connected to a tie rod or bolt. Anchor plates are used on exterior walls of masonry buildings for structural reinforcement. Being visible, many anchor plates are made in a style that is decorative. Then, we have the vertical anchor pile. But what is anchor pile? Anchor piles are required to resist lateral loads with or without being braced depending on circumstances, and an ordinary or standard house pile is required to carry a vertical load. The lateral load capacity of timber pile foundation system are set out in NZS 3604, which is NZS 3604 are timber frame buildings for structural designs on good ground. For the next method, we have the anchor beam with batter piles. These are anchor beams supported by batter piles, often are used to anchor sheet pile walls, especially where the subsoil is rock or good enough to support the pile loads. The anchor beam with batter piles should be located away from the active zone behind the retaining wall. Then let's go for the design of cantilever sheet piles. First, we have the case 1, sheet pile penetrating sandy soils, and for the case 2 is sheet pile penetrating clay. The given design cases will be discussed on the next slides. So this is the diagram for sheet pile penetrating sandy soils. To see the step-by-step procedure for obtaining pressure diagram, let's proceed on the next slide. For step-by-step procedure for obtaining pressure diagram is given below. First, calculate the Ka and Kp, which is the active and passive earth pressure based on Rankine's method or Coulomb's method. Then, calculate the horizontal stress at point C and point D, respectively as the sigma 1 gamma L1 Ka and the sigma 2 gamma L1 plus gamma B L2 Ka. After that, calculate for L3 using the L3 is equals to sigma 2 times gamma B Kp minus Ka. Then, calculate the P equal to the area of ACD. While doing this, you must look on the previous slide for the diagram. After that, calculate the distance of P from point E, called Z bar on figure, by taking the moment about point E. P has to induce equal moment to the pressure of ACD area. Then, calculate for sigma 5, which is the gamma L1 plus gamma BL2 Kp plus gamma BL3 Kp minus Ka. After that, calculate for A1, A2, A3, A4. By getting those data, you can solve L4, and after that, calculate for sigma 4, which is sigma 5 plus gamma BL L4 Kp minus Ka. After getting sigma 4, you can now gain sigma 3. Then you can obtain the L5, which is L5 is sigma 3 L4 minus 2p sigma 3 plus sigma 4. And now, draw the pressure diagram like the one given above, for which the depth of embedded is depth is equal to L3 plus L4. Now, for case 2, we have the cantilever sheet pile penetrating clay. Now you can get the pressure on the given diagram just by deriving its equation.
Anchored sheet pile. Anchored sheet pile walls are held above the driven depth by anchors provided at suitable level. The anchors provided forces for the stability of the sheet pile, in addition to the lateral passive resistance of the soil into which the sheet piles are driven. In this figure, you will see the pressure diagram and the moment diagram. In this figure, show the anchored sheet pile wall penetrating sand. Design sheet pile walls. A sheet pile wall obtains its pressure retaining function from the soil pressure, combined with the anchoring system and from the resistance of the wall against the bending moments and transverse forces. Also, many unknowns and factors that influences the behavior of the sheet pile wall. Examples: anchored sheet piles. Number 2, combined walls. Number 3, diaphragm wall and cofferdam. Cofferdams. A cofferdam is a structure that retains water and soil that allows the enclosed area to be pumped out and excavated dry. Cofferdams are commonly used for the construction of bridge piers and other support structures built within water. Also, cofferdams walls are usually formed from sheet piles that are supported by wallers and internal braces and cross braces. In this figure is an example of cofferdams. Types of cofferdams, which will be discussed in the next slide. First type of cofferdam is brace. It is formed from a single wall of sheet piling which is driven into the ground to form a box around the excavation site. The box is then braced on the inside and the interior is dewatered. It is primarily used for the bridge piers in shallow water. Usually, it is 30 to 35 feet or 9 to 12 meter depth. Second is earth type, constructed on land and floated into places. Lower portion of each cell is matched with contour of riverbed. It uses rock ballast and soil to decrease seepage and sink into place. Also, it is known as gravity dam. It usually consists of 12 by 12 cells and it is used in rapid current or on rocky riverbeds. It must be properly designed to resist lateral forces such as tipping, overturning, and sliding. The third one is the double-walled sheet pile. They are double-walled cofferdams comprising two parallel rows of sheet piles driven into the ground and connected together by a system of tie rods at one or two levels. The space between the walls is generally filled with granular materials such as sand, gravel, or broken rock. The fourth one is cellular cofferdams. It is used only in those circumstances where the excavation size precludes the use of cross-excavation bracing. In this case, the cofferdams must be stable by virtue of its own resistance to lateral forces. The last one is timber crib, constructed on land and floated into place. Lower portion of each cell is matched with contour of riverbed. It uses rock ballast and soil to decrease seepage and sink into place, also known as gravity dam. It usually consists of 12 by 12 cells and is used in rapid currents or on rocky riverbeds. It must be properly designed to resist lateral forces such as tipping or overturning and sliding. Advantage of cofferdam. Number 1. It allows excavation and construction of a structure in otherwise poor environment. Number 2. Provides safe environment to work. Number 3. Constructors typically have design responsibility. Number 4. Steel sheet piles are easily installed and removed. And last one is the materials can typically be reused on other projects. Cofferdam components. Sheet piling. Sheet piling is a manufactured construction product with a mechanical connection interlock at both ends of section. These mechanical connection interlock with one another to form a continuous wall of sheeting pile. Applications are typically designed to create a rigid barrier for earth and water, while resisting the lateral pressure of those bending forces. The shape or geometry of a section lends to the structural strength. In addition, the soil in which the section is driven has numerous mechanical properties that can affect the performance. Other components of cofferdam is bracing frame, and the last one is concrete seal. The typical cofferdam, such as bridge pier, consists of sheet pile set around a bracing frame and driven into soil sufficiently far to develop vertical and lateral support and to cut off the flow of soil and, in some cases, the flow of water. Cofferdam construction sequence. The figure will be properly shown in the next slide. The figure A for a typical cofferdam, such as for a bridge pier, the construction procedure followed the listed pattern. Pre-dredge to remove soil or soft sediments. Figure B, drive temporary support piles. Temporarily erect bracing frame on the support piles. Figure C, set steel sheet piles starting at all four corners and meeting at the center of each side. Drive sheet piles to grade. Block between bracing frame and sheets, and provide ties for sheet piles at the top as necessary. In the figure A, excavate inside the grade or slightly below grade while leaving the cofferdam full of water. Figure B shows drive bearing piles. Place rock fill as a leveling and support. Figure C shows place tremie concrete seal. In the figure A, shows check blocking between bracing and sheet. Next, dewatering and construct new structure. Figure B shows construct new structure and flood cofferdam. And last, figure C, remove sheet piles, remove bracing, and backfill.